Hello. Today we're going to talk about math, which I never talk about, so I'm a little bit nervous about it because I have never tried to explain a math thing before, or almost never. So I'm not sure how well it'll go. But we're going to talk about Euclid's algorithm. And the reason I want to talk about this is that one of my math teachers explained this to me when I was 17, and I thought it was the coolest thing, and it was one of the things that really made me fall in love with math and made me want to spend the next 3 years studying math and to major in math, because I was like, this is amazing. And it's a way to find the greatest common factor of two numbers, which is a relatively mundane thing. But I just think that the way you do it is so cool and it's so simple. And we're going to do it by writing code, actually. And it's just 6 lines of code. And I just think it's the greatest. So I'm not sure how clearly I'll be able to explain it. But let's see how it goes. So the greatest common factor of two numbers is the biggest number that divides both of them. So as a really quick example, the greatest common factor of 8 and 6 is 2, because 8 is divisible by 2 and 6 is divisible by 2, and there's no number that's bigger than 2 that 8 and 6 are both divisible by. And the kind of obvious way, maybe, or the way that you might first think of finding the greatest common factor is to factor both of them, right? So you're like, well, 8 is 2 cubed, right? It's 2 times 2 times 2, and 6 is 2 times 3. So you look for, the common factors. You're like, well, there's just 1, 2 in both of them, and so the greatest common factor must be 2. Another example of this is 80 and 78. And you could factor them and be like, okay, well, 80 is 2 to the power of 5 times 5, and 78 is 2 times 3 times 13, and the answer is, again, 2, because there's just 1, 2 in common. But if, for example, we were doing 240 and 78, there would be it would be 2 to the power of 5 times 3 times 5, and the greatest common factor would be 6. Anyway, but the point with both of these calculations is that we had to factor the two numbers, right? And on a computer, factoring is slow. It takes a really long time. If factoring were not slow, no encryption would work, right? The whole thing that a lot of our encryption is based on, or RSA is based on, is the fact that you cannot factor numbers quickly, especially very, very big numbers, right? 80 you can factor quickly, it's not a problem, but very big numbers you cannot factor quickly. But it turns out that to find the greatest common factor of two numbers, you don't need to factor either of the numbers. You can do something much simpler and much, much faster. It runs in log time. And so the faster way, if I was calculating the greatest common factor of 80 and 78, what I would do in practice is this, which is to be like, well, 80 minus 78 is 2. And so the answer is 2. And you would be like, Julia, what the heck? Right? You can't just subtract those two numbers. That doesn't, it's true that 80 minus 78 is 2, and the greatest common factor is 2, but that might be a coincidence, right? This does not obviously seem like a legitimate method. And you can't just subtract the two numbers. That is not all there is to it. But what we do, the algorithm we're gonna do is related to this. It's kind of similar. And I was thinking of explaining the algorithm in an abstract way, but I think what we're going to do instead, because kind of how I like to do math too, is run through a bunch of examples myself, by hand or on a computer. So instead what we're going to do is I'm going to show you the code, and then after I show you the code, I'm going to try to explain how it works. And it's only 6 lines of code, so it hopefully will not be that complicated to talk about. So I wrote this program called greatestcommonfactor.py, and it takes just 2 command line arguments that get passed to this function, GCF. And it has basically 3 cases. The first case is, I just want to make sure that A is bigger than B in this function. So I'm like, look, if A is less than B, just flip the order, right? And the greatest common factor of A and B is the same as the greatest common factor of B and A. It doesn't change anything. The second case is, I'm using this modulo sign. Let's actually talk about what that means really quick. So what this percent sign means, what this operation does, is it divides the first number by the second number and takes the remainder. So 8 modulo 3 is 2, and that's because 8 is it's something times 3 plus 2. So if you divide 8 by 3, you get 2 and the remainder is 2. 9 modulo 3 is 0, because 9 divided by 3 is 3, and then the remainder is 0. 18 modulo 4 is 2, because 18 is like something times 4 plus 2. And so what if something, like if 9 modulo 3 is 0, it means that like 9 is divisible by 3. So what I'm saying in this code is like if A is already divisible by B, so if we're doing like GCF of like 18 and 6, right, where like 18 is divisible by 6, 6 is obviously a factor of 6, and 6 is a factor of 18, so the answer is 6, right? Like we can just return 6. We don't need to do anything else. But if it's not, then we're going to do something weird where we're going to be like, okay, let's look at the greatest common factor of B and A modulo B. And I think to understand like kind of what's happening, it's easier to look at an example. So we're going to run this greatest common factor.py on the numbers 238 and 234 and 198. And the greatest common factor of these two numbers is 18. We can sort of check that this is true in practice if we want to here. We can be like, okay, what is 234 divided by 18? And we can see that it's 13. So like 234 is divisible by 18, and 198 is 11 times 18. So 18 really divides those two numbers, and it's the biggest number that divides those two numbers, so that's not like immediately evident. So, but like what is going on here? Basically what this is saying, well, to calculate the greatest common factor of these two numbers, we're instead going to calculate the greatest factor of these two numbers, and then we're going to calculate the greatest common factor of these two numbers, right? And so like what this code is implicitly saying is that like the greatest common factor of 234 and 198 is the same as the greatest common factor of 198 and 36. But like it's not clear yet why they should be the same, right? And saying that further is the same as the greatest common factor of 36 and 18. And we believe that the greatest common factor of 36 and 18 is 18, because 36 is divisible by 18. But it's not really clear why like either of these two steps is valid. So let's do a really concrete example and talk about why we're just going to talk about why the first step is valid. But the reason this first step is valid is the same as the reason the next step is valid, and it's also the same as the reason that this algorithm works in general. So let's try to do it. Okay, so we're trying to show that like the greatest common factor of these two numbers is the same as the greatest common factor of these two numbers. And what that kind of means, or like another way of saying that, is if any number that you can divide 234 by and 198 by is also divisible by 198 and 36, which is not obvious. Like, why would that be, right? Like, so, but you can see that it's sort of true, right? Like, 36 is divisible by 2, 198 is divisible by 2, and then also 198 is divisible by 2, 234 is divisible by 2. Like these two are divisible by 3, these two are both divisible by 3, these two are both divisible by 18, these two are both divisible by 18. And like if you look like concretely at the numbers, any number that these two numbers are divisible by, these two numbers are also divisible by. But why? Right? Like, why is that true? And like, yeah, because if that's true, then because if they have all the same like common factors, then they have the same greatest common factor, right? Like, yeah, So basically, what this is saying is that like the common factors of these numbers and these numbers are the same. But why? So I tried to write out kind of why here. So let's say that we have a number x. This is the x here, which is a factor of both 198 and 36, right? So, well, like, what does it mean to be a factor, right? What it means is that there's some other integer, a, where 36 is a times x, right? Like, for example, if x is 18, 36 is 2 times x. And 198 is, like, 11 times x. And the number 234 is 36 plus 198, right? It's just the sum of these two numbers. And what that means is that 234 is a plus b times x, right? So in this like in the example where like x equals 18, 36 is 2 times 18, 188 is 11 times 18, and 234 is 13 times 18. We can double check that that's true. 234 equals 18 times 13. Yeah, that's true. Yeah. So basically, because 234 is just these two numbers added together, if something is if like some number x is a factor of these two numbers, it's also a factor of 234. And so what that means is that the factors of these two numbers are the same. All also divide 234. And you can also go the other way and say like, well, okay, like if you have a number that divides that's a factor of 234 and 198, like let's say, I don't know, 18 again, right? Which is a factor of 234 and 198. You can be like, well, 234 is 13 times 18, and 198 is 11 times 18, and 36, because 36 is 234 minus 198. And so you can subtract them and say like, okay, like this is 13 times 18, 11 times 18, and then 36 is 2 times 18. Because you just sort of like subtract the C and the D there. And then you can do the same thing here. So like 198 is, how does this work? Right. 198 is like 5 times 36 plus 18. And basically you can go through the same thing and see that like if there's any number that divides both 36 and 18, it's also going to be a common factor of, like if there's a number that's a factor of 18 and 13, it's also a factor of 198 and 36. Of 18 and 36. It's also going to be a factor of these two numbers and vice versa. Yeah, and so that's why this works. Like that's why this like recursive function works, is because these two things are equivalent. The common factors of these two numbers are the same as the common factors of these two numbers. Yeah, let's do some more examples, because I think it's kind of fun to see this algorithm in action. So let's say we want the common factors of like, I don't know, 111, 111, and like 234, right? Like, I don't know what that is. It's 39. And you can see that it did it in just 3 steps, right? It was like, okay, we'll start with this 111, 111, and 239. We'll divide this by this, get the remainder. So that we know the greatest common factor of these two is the same as the greatest common factor of these two, which is the same as the greatest common factor of these two, and then the answer is 39, and that's it. And so this basically runs in logarithmic time. So even if I have like super big numbers, like I don't even know. It runs pretty quickly and doesn't need to do that many steps, which I think is really nice. And it turns out that these two numbers don't have any common factors. The greatest common factor is 1. But I guess if we put a 2 at the end here, they would both be even. So, well, then the greatest common factor is 2. But yeah, we didn't need to factor those numbers at all, right? And this like really simple algorithm that just 6 lines of code can do it. That's all I have to say about that. I hope it made a little bit of sense. I don't know. You can let me know in the comments. One nice thing, if you kind of want to extend this, is you can also do this with polynomials. So for example, if you have like the polynomial x squared plus 2x minus 15 and x squared minus 2x minus 3, and you want to know like which polynomial is a common factor of those, you can also like subtract them and use basically the same algorithm, where you like divide this one by this one and take the remainder, which in this case is just the same as subtracting them. And if you subtract these, you get 4x minus 12, which is like x minus 3, and x minus 3 is the greatest common factor of these two polynomials. Because this is x minus 3 times x plus 5, and this is x minus 3 times x plus 1. But like factoring polynomials is hard and annoying, and finding the greatest common factor, you don't need to factor the polynomials. You can just like subtract them in this case, and then you get the greatest common factor. And I think that's really nice. So thanks for listening. I'll post the code for this in the description too. And that's been my maybe only ever math video. I hope you liked it.